During our last video, we saw a fast approach to evaluate an integral when you have to apply integrations by parts repeatedly. In that process, the given integral was seen as a product of two functions, and one of those two functions was labeled as u and the other function was labeled as dv. Of course, that's how we begin integrations by parts process. When you have to repeatedly apply that integrations by parts formula, we keep on differentiating the function that was labeled as u, and we keep on integrating the function that was initially labeled as dv. The number of times that we integrate the function that was initially labeled as dv is equal to the number of times that we differentiated the function u. In fact, the function that was labeled as u is differentiated until we obtain a constant. In that video, I discussed a complete example, and at the end of that video, I gave you this question: integration x to the fifth power times sine 2x dx as a homework question. At least one of you had asked the solution of this homework question as well, and this video is made to discuss the complete solution procedure of this question. Alright, as always with integrations by parts, if you look at the formula, it is integration u times dv being equal to u times v minus integral v du. We need to select a function u and a function dv. Of course, the function that's selected as u should reach a constant upon a finite number of derivatives. Of course, sine 2x, no matter how many times you differentiate, will never become a constant. Therefore, the other function, x raised to the fifth power, should be selected as the function u. Of course, if you differentiate x to the fifth power one time, you get a fourth order polynomial. Differentiate again, you get a third order polynomial. And likewise, finally, you get a zeroth order polynomial after 5 successive differentiations. Alright, once the function u is clear, we label the other function as dv. To start this process, we write down u and dv. U is equal to x raised to the fifth power. And then I need to write down dv. However, dv wasn't written at the same level as u was written. In fact, dv was written a line above. dv is equal to sine 2x. And then I need v. Of course, if you pay attention on integrations by parts formula, the very first term is u times v. We already have u, and what I need now is v. dv is equal to sine 2x. That means v should be equal to integration of sine 2x, which is negative cosine 2x divided by 2. Alright, that's the initial step. After this step, what we do is we start differentiating the function that was labeled as u. We keep differentiating that function until we obtain a constant. Alright, let me start differentiating the function u. Let me write down the first derivative as u superscript 1. It will be equal to 5 x to the fourth power, which is not a constant, therefore I need to differentiate again. Let me write it down as u superscript 2, the second derivative of u. It will be equal to 20x cubed. Even that's not a constant, therefore I need to differentiate again. Let me write it as u superscript 3. It will be equal to 60x squared, which is also not a constant, therefore I need to differentiate again, which will be written as u superscript 4. In other words, the fourth derivative of u, which is going to be equal to 120 times x, which is also not a constant. Therefore, I need to differentiate it again, which will be written as u superscript 5, which is the fifth derivative of u, and it will be equal to 120. Alright, after 5 successive differentiations, we have reached a constant. Therefore, we stop at this point. Since we differentiated u 5 times, now we pay attention on our v, and we need to integrate v also 5 times. Let me start doing that. The first integration of v, I will write it as v sub 1, which will be equal to negative half times integration of cosine 2x. which is equal to negative 1/2 times sine 2x divided by 2, which will be simplified to negative sine 2x divided by 4. I need to integrate it again, which will be written as v sub 2, which is going to be equal to negative 1/4 times integration of sine 2x, which is going to be equal to negative 1/4 times negative cosine 2x divided by 2. It will be simplified to positive cosine 2x divided by 8. I need to obtain the third integral of v, which will be written as v sub 3, which is going to be equal to 1/8 times integration of cosine 2x, which is equal to 1/8 times sine 2x over 2, which will be simplified to sine 2x divided by 16. We need to integrate it for the fourth time, which will be written as v sub 4, and that's going to be equal to 1/16 times integration of sine 2x, which is equal to 1/16 times negative cosine 2x divided by 2, which is negative cosine 2x all divided by 32. I need to integrate v for the fifth time as well, which is going to be the last time I need to integrate it, which will be written as v sub 5. This is going to be equal to negative 1 over 32 times integral cosine 2x, which is equal to negative 1 over 32 times sine 2x divided by 2, which will be simplified to negative sine 2x divided by 64. In the next step, we multiply the corresponding u's and v's. First, we multiply u times v, and then we multiply the first derivative of u with the first integral of v. And likewise, all of those corresponding u's and v's will be multiplied. Those multiplications must be linearly added. However, in addition to straight across multiplication of the corresponding u's and v's, we should also distribute a corresponding plus or a minus symbol uniquely associated with each product. If you pay attention to the integrations by parts formula once again right here, the first term is a positive term. The second term is a negative term. Therefore, we need to maintain that plus minus pattern as you go down with repeated application of integrations by parts. Therefore, for the first product between u and v, we need to distribute a plus sign. For the second product between u and v, we need to distribute a negative sign. For the next product between u and v, we need to distribute a plus sign. And for the next product between u and v, we need to distribute a minus sign. For the next product, a plus sign should be distributed, and for the next product, a minus sign should be distributed. Alright, with all these things in mind, now we can write down our final answer. The question given was integration x raised to the fifth power times sine 2x dx. The answer begins by multiplying the first u and the first v, and by distributing the first sign. For the first product between u and v, u equals x to the 5 and v is equal to negative cosine 2x over 2. And the sign to be distributed is a plus sign. Therefore, the first term will be equal to negative x to the fifth power times cosine 2x divided by 2. We are done with that. Now we look at the second line. In the second line, we have to multiply 5x to the fourth and negative sine 2x over 4, and we have to distribute a negative symbol. When we do that, it will become a positive term. Therefore, let me write it as a positive term. 5x to the fourth power times sine 2x divided by 4. We are done with that second product as well. Now we need to pay attention on the third line. We need to multiply 20x cubed times cosine 2x over 8. They both are positive, and I need to distribute a positive symbol. Therefore, that third term will be written with a plus sign. 20x cubed times cosine 2x all divided by 8. Alright, then we go on to the next line. In the next line, we have to multiply 60x squared and sine 2x over 16, and we need to distribute a negative sign. Then it will become negative 60x squared times sine 2x all divided by 16. We are done with that as well. We go on to the next line. We have to multiply 120x times negative cosine 2x over 32, and I need to distribute a plus sign. When we do that, the answer becomes negative 120x cosine 2x all divided by 32. Alright, and then the last product. We need to multiply 120 times negative sine 2x over 64, and we need to distribute a minus sign. Then it becomes a positive term, positive 120 times sine 2x all divided by 64. That's all about multiplying u's and v's. However, this is an indefinite integral, therefore we also need to add a c, where c is an arbitrary constant. This is also not all, because we can do some further simplifications. If you look at this term right here, we can see some common factors. 4 is a common factor between 20 and 8. Therefore, I can divide top and bottom by 4. 20 divided by 4 is a 5. 8 divided by 4 is a 2. Alright, then we can pay attention on this term. Once again, that term also has some common factors. 4 is common. 60 divided by 4 is 15. 16 divided by 4 is equal to 4. Then we can pay attention on this term that also has some common factors. 8 is a common factor. 120 divided by 8 is equal to 15. 32 divided by 8 is equal to 4. And then we need to pay attention on this term, and 8 is a common factor again. 120 divided by 8 is 15. 64 divided by 8 is equal to 8. Alright, we can now write down the final answer as negative x to the 5th power cosine 2x over 2 plus 5x to the 4th power sine 2x over 4 plus 5x cubed cosine 2x over 2 minus 15x squared sine 2x over 4 minus 15x cosine 2x over 4 plus 15 sine 2x over 8 plus c. Alright, so that's our final answer for that homework question. I hope you enjoyed this video. Thank you so much.